Hello everyone and welcome to Golang Montreal Blockchain Edition. It's an EOS Blockchain and Go edition. We're super happy to have you. We're going to have some great time, I think. Maybe some of you guys know there's a global hackathon called Til Dawn. And it's going to run for 2 weeks. And it's teams from all over the world are going to race and ship the best distributed applications they can on EOS built in that short time frame, right? It's some social thing. It's not at a precise location. It's worldwide, and there's huge prizes to win. And why we wanted to do that today here, I think it's tremendously useful to give the community, the Go community, an unfair advantage by showcasing different tools we've been building for those teams to be faster in using the EOS blockchain and building dApps a lot faster and easier. So don't hesitate to join us on our Telegram channel or on other social properties, and we'll answer the questions during the whole hackathon, okay? That's also sort of the reason for why we're doing this today, because it's a kickstart of the Til Dawn Global Hackathon. Today, we're going to see a few things, okay? We're going to boot an EOS node. You'll see with the tools we've built, it's pretty fast and quick. And then we're going to learn about how EOS built its data structures, okay? So we're going to get down to the meat. I expect we have a lot of people who are developers here. Raise your hand if you're a developer. Raise your hand if you've developed for other blockchains before. We're going to expose a small dApp, okay? We'll have a contract we're going to show you, and then we will interact with that contract on a chain, a living chain, all in Go. Okay, we're going to start by showing how the app works. It's a pretty interesting employee rewards program, I think. And then we're going to code a Go command line tool so that we can interact with the blockchain. Does that make sense? Yeah. So I think it's going to be from meetups I went to, signal to noise, where we have more concrete stuff. It's going to be exciting, I think. Okay, so just as we go, EOS is also a currency, but this is not financial advice. Okay, you buy EOS if you want. It's not my business, and if it goes down, I don't want to be held responsible. So this is not. This is just programming. Okay, and so the demo today is based on the release Dawn 3, which was released 3 weeks ago. It goes at a crazy pace in that space, and a new release is scheduled to be dropped on May 11th. That's Friday. We will upgrade our library to reflect the changes on May 12th, May 11th. But this here is code that works today on Dawn 3. Now what we're going to do, we're going to boot a node. Now, some of you guys might know that we're block producer candidates, and we've built a tool to launch networks, EOS networks. It's called EOS BIOS, and we think it's a good contender to actually launch the main net, the EOS network, in June 1, 2, 3. We'll see how that goes. And I think it's the most complete tool to date. And we developed a protocol for anyone to join. It's very exciting. And then it's fully decentralized, and people can start and register as block producers on that system and eventually launch the mainnet together. And it's all that boot tool that you can also use, because it's a Go program. You can use it locally on your own machine and boot a node in Docker. Poof. And it has the same thing. Whoops. Has the same thing as you would have on the mainnet. How exciting is that? Yeah. This here is the sample configs in our GitHub repo there, EOS BIOS. And in there you have everything you need. There's quite a few files, some are just temporary files, to launch a node. If you git clone EOS BIOS, you go to that directory, and you download EOS BIOS, the only thing you need to do, you see that? EOS BIOS boot, is to run that command. Is it going to work? I'm going to cross my fingers. Now, this is when you orchestrate a launch, that piece of information would be shared with everyone so that they can join the network. Okay, but right now I don't have anyone to join the network. I'm just going to hit enter, and I'm going to write the previous data in my blockchain, and then it's starting through Docker. Okay, so that works on Mac, Windows, Linux, whatever. And if you look at the logs here, you see that the node did launch, and it discovered there was no storage, so it started a new chain. It started generating blocks. Okay, generating blocks. Raise your hand if it's clear to you what generating blocks is. Okay, generating blocks, in Bitcoin, blocks arrive at each 10 minutes, and it's a set of miners that waste a lot of electricity to create blocks. On EOS.io, we have block producers, which are highly visible entities like us, right, EOS Canada, and they are voted in to produce blocks. There's 21 of those, and so it's very efficient. You see the pace at which blocks come through here? That's 500 milliseconds. So, if you don't know yet, EOS is one of the craziest and most performant, if not the most performant blockchain ever. Okay, so we're now producing blocks. That means the state of the blockchain can change each 500 milliseconds. If you send a transaction in, it can be applied to the blockchain and have consensus throughout the world in 500 milliseconds to 1 second for irreversibility. I won't get into those details. We'll have some other videos and other sessions about that. So now we've started the node locally, and now we're going to roll out the boot sequence. The boot sequence is all the steps we need, because the blockchain initially is an empty can. It really has just a few semantics, but the meat is inside smart contracts. Actually, EOS, the EOS network, does not need a token to exist. But there is a smart contract where we emit a token, the EOS token that you know, which is going to be honoring the ERC20 snapshot on Ethereum. It's going to be injected in a smart contract. It's just another smart contract, which makes it very easy to cross-program and to interface with during, like, when you're doing your own smart contract. We're going to see that today. So right now I'm going to hit enter, and it's going to go create the accounts, inject the code, and you'll see it's also going to honor. Woohoo! That's too fast. So I hit enter there, and I'm setting the system code, setting system contracts, setting privileged account. It's putting the meat inside the chain, okay? I'm issuing the first monetary base, that's the billion coins there, and then we're creating the initial block producer account so that they can join in the network and start producing blocks using a schedule, and then we're injecting the ERC20 snapshot. That's honoring all the people who have bought EOS on Ethereum, right? So right now we're truncating that list to 5,000 just because we're testing. Otherwise, there's 100,000 lines maybe in there when we launch. And then we're going to disable the system account. And this will make the chain very, very similar to the prod, to the mainnet, all the same contracts and all, okay? And now there's that private key. Now it's public to you guys. I'm going to add it to my wallet so I can sign transactions. After that, if you have any questions about that, you can, just come out of file. So, yes, wallet, import. That's the key. It's going to be good. Okay, so I imported that. Now in the background here, I have the eos-D, which is a wallet that stores the key, and we call it to sign transactions, and we push to the chain, okay? If you want more details about that, you can raise your hand, and I'll try to answer the question. So, are we good with that? Now we have a chain that is fully launched. If we look at the logs, it's now producing blocks. It did push in all sorts of transactions at boot. And now we're at block 620, 618. I'm going to introduce a little D app we're going to work on today. The D app is, I don't know if you know Shopify. Shopify is a great company I admire a lot. And they have internally, they published that in 2011, they have there an employee rewards program. It's actually a social platform there, and you can post something about someone else. So you say, hey, a pat in the back, you did some great job with that mobile app, or thanks for, I don't know, putting some nice painting on the wall. And so people go on that site, and they can +1, right? Vote 1, 2, 3. They're called unicorns, or they unicorn one another. And so that weights in their algorithm. And at the end of the month, well, because management are all coders, they coded that at some point, linked to their accounting system, they put some money in, and it's distributing the money according to those weights and algorithms that people voted, posted, and all that. How cool, right? So it's a great way for employees to get a pat in the back and encourage people to encourage the other folks publicly and then vote for it. So that's what we're going to do. We have a contract that implements that, and I'm going to show that to you. And then we're going to create a Go program to interact and do the posting, do the votes, and send some money and see it blasted out. Okay? We could actually use that at a company. It's our goal to have that at our company. So, let me show you a piece of the code there. Now, I'm going to answer someone's question here. this is the code for the smart contract called Shine. Shine is the employee reward program. It has 3 methods. Let's just concentrate on 2 here. It has a post method, and it has a vote method, right? And you can say, I'm voting from who am I posting to, and what's the memo, so why, for the painting, for whatever. And then vote, you can take the ID from that thing, and then vote, like +1, right? And then you can imagine hooking that, as we go, hooking that to a bot. Like on a chat, where you have people recognize some other people and vote with some click. So you guys will do that. Or us if you're not fast enough. So, and the algorithm rewards people who do different things. It rewards, like 90% goes to those who have received a post or a vote, right? And then 7% in that case are for those who did posted to others. So we're rewarding also those who participate and also, want to reward others. And also for those who vote. If you vote, you also are incentivized. A smaller rate, right? But you're into the game. So what we're going to do is, I don't know if you noticed this code here. This is C++ code, okay? Now let me give a little topo on that. C++ is currently the main language used to develop on EOS. And there's many reasons for that. EOS is the first blockchain to ship using WASM, so WebAssembly. Raise your hand if you know what WebAssembly is. Great, so WebAssembly today is in all the browsers of the world and your pockets. WASM is the assembly level language for the web. So it's supported Microsoft, Google, whatever, all the Google and missing someone, Apple there. And they're developing that to run untrusted code in the browser that is highly optimized. So you can imagine in the future, you could run Adobe After Effects and do some like very powerful mathematic whatever in your browser tab. Because WebAssembly will allow us to get those performances, not just JavaScript. It's a second VM in the browsers. And EOS said, like, this is a great thing, and we're going to use that instead of reinventing our own. And you know what? Developers are going to use that because they're going to develop for the web anyway. So the tooling for WebAssembly is also going to be repurposed or reused or used for EOS, which makes it a very great target for developer eyeballs. So you want to learn those things. Today, the best tooling for WebAssembly is C++. There's also some things in Rust being worked out, but the most proficient tooling, C++, is what we see now. And that compiles to WASM. And WASM is a bytecode, and it looks like assembly. It's a bytecode, and then it's decoded in the browser. Or in our case, we're going to push it to the blockchain, and that's what's going to be executed. We're not going to ship JavaScript. We're not going to ship Python. We're shipping bytecode. That's very efficient. So some people ask, can we code smart contracts in Go? The truth is, perhaps we can eventually, but right now, the WASM toolchain, and by the way, it's getting built inside the main Go repository. We'll be able to run WASM code, to build a Go program directly into WASM. But I tried that, and the binary, the hello world, is 9 megabytes. So there's a lot of things in Go that makes it not like that efficient. You don't want Go routines. There's many things in a blockchain you don't need from Go. So eventually, maybe you can tree shake things in Go, still use the semantics and the tooling to eventually build smart contracts, but that's not the truth today. Okay? So does that answer the question? Because you had that question. Now we're going to go to Shine. And so I added already my my wallet. So I'm going to add the contract. So you have the code here. It's been built as WAST. And so this is the text version for the curious of the WebAssembly. See how it looks like WebAssembly, and it's very low-level, sort of operations that store. It's assembly, basically. Okay, but it's still readable. You have ifs and else in there, so it's pretty interesting. And what we're going to do is we're going to inject the contract in the chain. Now, EOS has an account system, a beautiful account system. It allows you to create a named account. It's not just like a big pile of undecipherable characters that's 65 characters long. You have a named account. Actually, they're maximum 12 characters long. So we're going to create an account for Shine. And just posit that. You have the code for a smart contract and an account, and you have, per account, only one piece of code you put in. An account can live without some code. You can store some money. An account is also for some users. But in an account, you can put some code and only one piece of code. Okay? And when you call a contract, you're actually calling that account with a method, post vote, like we have. Is that clear? So now we'll create an account on the chain. Let me show you how we do that. This is the main EOS tool is the command line tool. So notice how EOS is in the command line name. EOS. That's the part. So EOS, you can say create account. Then you give it the source account, right? Because in EOS, you always create an account from another account. It's like a Gmail invite, right? You need to be there to create other accounts. When the net launches, everyone who had ERC20, more than one EOS, by the way, will have an account automatically. So they can invite the other folks, right, and create an account for them. So we're going to create an account named Shine. And look, we're going to reuse the public key here. This is a public key. So normally you would not create many accounts with the same private key or public key, right? You would have each user have their own keys and properly secure them. For the demo, I'm just going to use the same key everywhere, so it simplifies signing. Does that make sense? It's going to be awesome. Now we're going to give the owner key and the active key. This will create an account using the owner, the creator, ESIO. The name of the new account is going to be Shine, and these are the keys you'll need to sign with if you want to sign transactions. Okay, let's try that. Oh, there we go. It works. So now we have an account. You can say get account Shine. And see how we have the return. This is the beautiful permission system. We're going to have some other videos and some other talks about that. But it's a very neat on-chain way to manage security with different, like multi-sig with a threshold and a weight and different keys and deferring to other accounts also. So that's what was created by the create account there. So we're going to create also accounts for a few folks that are employee at our company. And let's create the account for, so Joe, right? And then Jane, and then also Alice. Is that clear here? And then Bob. So we have 4 accounts. Make sense? Next step, we want to inject the contract in the chain. We're going to inject our Shine code that was built here in which account? The Shine account, right? Because that's where the code is going to live. That's who we're going to call. Who are you going to call? Shine. So, to do that, we're going to call EOS again, and we're going to set contract on the account Shine, and we're passing the local directory, if I remember correctly. Okay, so when you contract, you give it the account you want to push contract, the contract dir, and the name of the files. Okay, so we're going to do that. So Shine, the contract dir is here, and it's going to be shine.wast and shine.abi. ABI is the application binary interface. If you have questions about that, we'll have that at the total end. And you can look at the details. It maps like how a JSON representation maps to bytes, right? Okay, so will that work, man? I hope. Okay, it did. So it's set on the Shine account, the code and the ABI. And now we can say get code Shine and see that indeed there's some code there. That's the hash of the code. Great. Okay. And once we've done that, like I want to show you there's a few tables. Remember that table posts and that table vote? This is actually world readable through the API. So what you can do is you can, sorry, that's not the right one. That's one, right? With vote rows. And you can read all the rows with EOS, get table, Shine, and that's the scope and the name of the table. Right? And posts and votes. And then if you load something like Super Mama, you don't have that table. It's not defined, right? So these tables, we're actually going to populate those. So let's try that right now. We're going to send a post and try that code in C++. So to do that, we're going to push an action. Pushing an action is like sending a function call on the chain. It's pushing it over there. You need to sign with the proper authority. And this is very similar to, let's imagine a MySQL. Raise your hand if you know what MySQL is. Let's imagine MySQL, and you don't have that in there, but you have stored procedures, right? The smart contract is a little bit like a stored procedure, and when you call it, it's going to change the internal state and then commit it, right? But at the same time, with a blockchain, you need to sign that command to call the thing I just said. The stored procedure, you're good. So the stored procedure, but you sign, so you're only able to use the stored procedures to change the state, and you need to have proper authorization. That's what makes it an awesome distributed database. Anyone can write to it if you have proper authorization, and the code determines how it goes. So when we're going to push an action, we say push action, the name of the contract or the account we're sending code to, and then the name of the action. So post vote, right? So destination and function. That's going to be, let's say, post, because we want to try it. And then over here, we're going to add, let me show you that, a JSON object. That maps very closely if you look at post here, right? The from, the to, and the memo. Okay? So from, that's going to be from, let's say, Joe says that. We're going to say to, and that's going to be to Alice, and the memo is going to be thanks for the painting. Okay? Now, is that going to work? Oh yeah, who did that? Okay, that's going to be better. Now I need to sign that transaction with the right permission. So I'm going to say, who needs to sign that? Like, you don't want people to be able to sign post as it was coming from me, but you don't have my authorization, right? So you're going to sign with that permission of Joe. You're saying, use Joe's keys to sign that. And like I'm going to show you in the code. So this succeeded. I'm going to show you in the code how that works. If you go to CPP, like this here says, okay, on the blockchain, this is going to verify the signature of the transaction. You cannot send a post without having properly signed with the from field, right? So when you say from Joe, you don't have Joe's signatures. This stops right away, and the transaction is invalidated. It's not even propagating through the network. Okay, that's cool, huh? It's better than stored procedures. Okay. So now what we'll see here is that if we get table, not super mama, but posts, see what we have in here? Like if I EOS get table shine, this is the scope here, okay? Another little thing in there. It's very fun. And then you have basically just a list of tables. So that is a hash map. So it's a key value store based on an ID. In that case, you can have multiple indexes with the multi-index thing I showed earlier. Okay? And then we can have a vote and all that. But now let's go to the Go part. Let me give you a quick overview of the Go library. And then we're going to do those operations using a Go program. Okay? It's going to be fun. So the Go library is documented here. It's on EOS Canada, eos-go. It's on our GitHub. It's open source, mid-licensed. And it has, the first thing is the API. So all the calls to any blockchain instance are wrapped into that. And you can, the most important bit is, I think, the signer and the sign push action, which is just like the push action we have on the command line. It'll take an action which is structured as a beautiful Go struct, and then it's going to do the signature, and send it to the blockchain. Okay? And then we also have, this is really cool. It's the first peer-to-peer implementation. So the protocol where the protocol that connects the nodes in between themselves is not an HTTP protocol. It's a TCP protocol called the peer-to-peer protocol, and it does a few things very simple. It sends blocks and sends transactions, and it sends blocks and transactions, right? But in there you have the core data flow. You have transactions before they're embedded inside a block, right? So this Go library handles like being a client, so you can connect to the peer protocol and discuss and see the transaction coming in and out. So that's great for any tooling you want to build around the protocol. It's the first implementation. The Node.js doesn't have that. C++ has it, but it's not as easy to work with. And Go is just perfect for distributed systems where you want to have data flows coming back and forth and talk directly to the node. So I'm super proud of that. And another thing is that we have the structs for most contracts, system contracts, right? The new account thing that we had earlier, creator and new account that I had on the command line. Well, then we also have a Go version of all that, so you can easily build things without the EOS command line tool and build that in a single binary and ship it across platforms, right? So that's interesting. And also, so the library manages all the packing and unpacking. Like 220, where's that? Types test. So that's the one. This is an example Go structure, right? And this is how it's marshaled when it's on the wire. Now you're going to ask, what is that, right? So the marshalling algorithm, can you list it here? That's the threshold. Here's 32 bits for the first, so it gets its 32 bits here. And then if you have a list of something, it's serialized as 0 is the number of things in that list, it's a var int. And then you get the pub key that is in the key weight, right? You have the public key there, and then you have a weight, 60 bits. So all that marshalling and marshalling is done by the library. So you just work with beautiful Go structs in the sense of the blockchain the way it should, right? How fun is that? Do you have any questions? You don't, huh? Last thing is the ECC. So the library here also handles signature. So let me show you a little thing. So the ECC library wraps the private key, public key cryptography, takes that from the BTC Suite Bitcoin implementation. There's a few tweaks there. And you can actually create your own wallet implementation. You've seen there was eos-D. eos-D there is to manage private keys. Now let me show you. This is a wallet implementation in 105 lines. This is Go. Of course it's Go. And these are the keys that are loaded in. And this is our implementation of a wallet. You have a key bag, you can put some private keys in there, and you can easily assign it. And we'll see that in the other part. You can use a key bag to sign things. So this is the endpoint that Chaos supports. Getting public keys, it's as simple as listing what you have in memory, and then signing transaction will also take the keys in there and sign it and send it back to you. So a few lines. With that, you could implement your own very funky Shamir secret distributed, like, I don't know what, like vault system with just a few primitives, because it offers all these things. I think it's really cool. So it's a very extensive lib. It's I think, the reference Go lib right now. And hope you all use it very soon. Raise your hand if you know Cobra. Oh, you're good. You know Cobra too. So Cobra is a library to build command line tools. It's just a very good library. It's built by Steve Francis. He's at Google now. He works on the Go team, and he built that before. It's probably the reason why he's there. And so we're going to use that. You'll see it's very easy, and it supports all the bells and whistles. That's what is used by kubectl and a few other high-profile tools to manage a command line. Okay, so we're going to start coding in Go now. Are you happy? But what I want to do is I'm going to use Cobra, which has a command line tool, to initialize a new program. And it's going to, China, whoa, man. So we're going to create that. It's going to create the directory and run a main in there. Okay? And it has, let me show you what that says. So shine main. See? And it refers to all the commands in a subdirectory called cmd. And then in there you have root. So the command there is shine. Let's take out all these comments. The top level command is not going to do anything. We're just going to defer to subcommands. So let's imagine what we want to do is do something like shine post from Joe, and it's going to have a 2 and then the memo. Okay? We also want to have vote from Joe and let's say a post ID. What about that? Will that work? That's the goal here. That's what we're building. An interface to our contract. So to do that, like the -f is going to be a persistent flag, and it's going to be a string. So let's put it here. So from account string, and we can take that one out. And the persistent flag is going to be here from account. And if we have a little p there, we can have the short version. That's going to be the default value, and that's going to be from. So the long form is from, short form -f, and that's going to be from account. Okay, does that make sense? We don't want that one, we don't want this. You actually don't even want a configuration file. This handles the configuration file, we don't want that. Okay? So right now we have no such post and vote command. It's just a flag that is global. I'm going to create now, with the command line tool, Cobra, add, vote, and post. Okay, that's good. So it automatically goes in hooks. And if you look at these files, whoop, where did it add that? Sorry, and post. So, whoa, man. We'll get there. So there we have it. Post and vote. And then the post is already created with the post. What we want here as usage is and then account and post to and memo, right? We don't want a description. And in here you can imagine we'll want to create an API client. We want to create the action, sign it, and push it to the blockchain. Does that make sense? That's what we want to do, okay? And then what is in there? I don't think we need anything else in code. Do we need anything else? No, we just need positional arguments. So to do that, we'll say ars cobra exact ars 2. It's automatically going to say, does that work? Exact ars. No. Extract. Who said that? Exact. Okay, that works. So that's the command line is all automatically going to say, oh, you don't have enough parameters, whatever. Okay? So if we cut, let's try that now. I want to do go install -v, and if that succeeds, shine, the binary is going to be installed in my go path, and I can just use shine, okay? Does that make sense? Shine, and I will say post, and it doesn't compile. I didn't run something. There we go. It compiles very fast because it's go, and then we have the documentation there. Okay, and let's do the vote at the same time so we know where we're going at. And the vote, we want that to be from, so that from, and then post ID. Okay, so for that we're going to add a flag. We want to have a flag like that. It's going to be an int, and we'll have a var so we can store it in something like vote post ID or something like that. That's going to be called post ID, and the short form is going to be P. Does that make sense? And that's going to be the post ID. So default value here is going to be 0. Is that going to work? So that vote post ID, so Cobra writes it here. Vote post ID and int. Okay? Does that make sense? Post. Post. Who did that? Vote post ID. Okay, we can take out the rest, so we have satisfied our interface. Now what we want to do in there is going to be very similar to the other side. Okay, we're going to copy the rest at some point. Let's try the post now. So we're going to use the library to create an API. Okay, so we can use EOS new, and then if you see down there, the arguments is a string and a chain ID. Now a chain ID, and we're going to create one empty one like that, 32 by 32. A chain ID in the EOS world is something that uniquely identifies one chain. You can have many EOS chains that communicate with one another, scaling the thing through stellar reaches, and they're all going to be identified through a chain ID. We're going to tell our endpoint we want to interact with that chain ID. Okay? So right now the chain ID, if we do a make like that, it's all initialized to 0. 32 bits is a hash or something, I don't know what, but we just pass it as a second parameter. And I'm running the node here on localhost 8888. Okay, it just happens that my script there ran node EOS, the blockchain, on that port, so I'm going to interact with that port. Does that make sense? And so we have the API, and we could go and dive and discover what we need, but what we need, I might have shown you earlier, we want sign push actions. Let me show you the code for the new account command. Remember that new account where we want a command line create account? Behind the scene, it calls the new account action on the system contract. And the code, the Go code that does that is here. It creates an action, and the important bits are these, okay? We're going to take a look at that. This is specific to the new account, and this is the structure we're putting in there, like specific to that action. We're going to create our own, which is going to map post and vote here. Okay, but let me give you a quick glimpse of that here. An action, so first of all, in a transaction, you can have one or multiple actions. Okay? In one transaction. So that's already fun. And an action is always geared towards one account, pointing to some code, right? And remember, code is in an account. So the line here is pointing to the account we're sending the action to, and the name is the name of the action we're calling. In our case, it's going to be post and vote. Does that make sense? Okay? And then authorization is we're indicating with which authority we think we need to sign, right? So when we put that in, we send it to the wallet's going to say, okay, I'm going to find the keys for that account, I'm going to sign the transaction and then push it to the blockchain, and hopefully the blockchain says, yes, you do have the proper authorization. Okay? So it's part of the knowledge of the action over there, of the source code, that you put the proper authorization. In our case, it's going to be when we post, we want to post from. We don't want anyone else to impersonate us. Same thing for vote from, or the vote would be. So what I'm going to do, I'm going to copy that. Right? It's in here. I'm going to copy it, and we're going to tweak it a little bit in post. So we want to do the post now. I'm going to paste these things. So we're going to take out everything that is specific to new account. Right? Down to here. We're going to place that by a post, and that post here. Post. We're going to see. So we're going to put in that object the fields that are listed in the contract. Remember the contract? Shine CPP. So the from, to, and account. It needs to map the type, because it needs to be serialized to something both ends understand. It's going to be serialized as a byte stream. Remember that byte stream? And so both ends need to unpack it the same way. So we'll say from, to, and memo. We'll say from is going to be an EOS account name. Right? And then we're going to have to there. And we're going to have the memo, which is a string. Beautiful Go format. Okay, and now the parameters we want here is actually new post. And the first parameter is going to be a from to memo. We'll all make those strings. Okay, simplify. And we'll cast them down here. Is that here? We're targeting the Shine account. When we send the action, we're targeting the Shine account with the action called louder. Okay. Account name, and so this is just a few helpers we had in the file. And then this here is going to be the from. Right? We want it to be signed with the from. And then the permission here, permission name is going to be active. So the beautiful account and permission system has different levels. You have owner authority, active authority, and you can create some other authorities to dispatch in a very granular way what keys can do which operation on the blockchain. That's for another day. And then in post here, we want to do from, and then we're going to use that here, and then to, and then the memo, right? Does that make sense? So we created in Go the interface to talk to the blockchain on the other side, to the smart contract in Go. Now, we're really inches away. We don't need anything else here. We have the API, and what we need to do is just say we want a new post from, where's from? From account, our 0, which is our 2. Okay, exactly over here. So from account comes from the command line in root, remember? The command line has a persistent flag. The -f is going to write to that global variable, and that's what we use here. Make sense? And then arg0 is the first argument we have there, and the second is the second we have there, so it's going to be 2 and the memo. So, sign push action. This can't fail, so let's make sure we handle the error. The first parameter is reply from the server. I don't care about the reply from the server. And then we'll fail if anything goes wrong, okay? We try that. Do you think it's going to work? If I just up arrow here from Joe, there's an extra comma at the end, so you better learn Go, man. You're going to see, you're going to see. So we're going to send something to who? Bob, and a great memo. Okay, let's cross our fingers. Is the extra comma going to be? Oh, shoot. So where's that? In vote. Oh, who modified that? I'm going to try that again. It wasn't in the file we just edited, just so you know. And then, oh! Now we don't have any signer configured. Like, are we about to send a transaction that is not signed? It's totally useless. It's going to be refused by the first node. It's going to say invalid signatures. So what we can do, the Go library provides two things. It provides a wrapper. We're going to use it here. Set signer. A wrapper wallet signer around the kiosk D wallet. Okay, so it has an interface that when you say sign, it's going to call through the RPC, that EOS wallet, and then give you the sign transaction, which you then push to the blockchain. And there's another option, which is the key bag, which is all in memory. You don't need to have another blockchain. If you load the keys in memory, you can use that to sign the transaction, which is really neat. So now what we're going to use is the remote one, okay? So we can create a new, and the endpoint there, I have the wallet running on port 667, okay? That, and it's going to be the same chain ID over there, TAC. And we need to specify somewhere the default. So the wallet signer, no, what is it? New. Who did that? So the second parameter, like the Chaosity has, you can have a named wallet, a default plus other named wallets. So that's why we put default down there. Okay, and then we set the signer, and now, do you think that's going to work? Still a comma? Post call. Okay, so remember Joe, great memo. What if we list the table posts? Woohoo! So now we did write to the blockchain using our lib, and see how terse and beautiful the thing is, right? It's so Go-esque, don't you think? And so post, you can add many actions this way, and you always have a trailing comma in Go, which makes it beautiful because you don't modify 2 lines in your git diff, right? If you only modify 1 line, and that's a feature. Now let's do something very similar for vote, right? I'm going to copy that. Obviously, you wouldn't want to duplicate that. You'd refactor that, but we won't do it today. And we put that in the vote. Woo! So it's going to be vote call, and then we're going to change a few things in there. So I'm going to do post to vote. Are you following me? Huh? Post to vote, Now what's the syntax for vote? Remember that? First is voter, and someone has great eyes. Voter, and then the rest was what? Post ID, right? And I think if someone is correct, then post ID is HPP. Post ID is what? uint64. So we're going to use that also in our code. And these native types, uint64, are going to be marshaled properly using the packing and unpacking mechanism. Okay? Post ID. Okay, and then we need here a voter, just because, and then we're going to have a post ID. Here's going to be a uint64 of a post ID. Hope we get somewhere. Where do we get that? From string, and then post ID. Let's say this is an int. You know why? Because this provides us with an int. So we're going to cast it here. Okay? Is that fine? And when we new vote from account, and we're going to have a post ID, which is what? Vote post ID. Is that all? Does that make sense here? So new vote, we're going to assign another. It's the same wallet, same endpoint, chain ID. We're just changing the action. The action is new vote.
Vote for yourself?
Sorry?
You vote for yourself?
No, it doesn't mean you vote for yourself. So if I'm going to use that, let's try it.
Okay.
My goal is to run vote, and then I'm voting from someone, right? It's always a user voting something. But you're going to vote on a post. Someone else posted someone for someone else. I want to vote on that, right? You don't want to create a new post, just want to vote on that. So right now, I want to vote on the ID 1, because it has a great memo. So from is going to be, let's say I'm Alice now. I'm going to vote, okay? And I'm going to vote for the ID 1. Oh man, what is that? Okay, so we got a minute. That's an error message that is sent from the server because the validation of the exception of something didn't go right. Now, I agree, this is not the best error message, but it's improving every day. So now we have a post ID there. And we're oh, you know why? Who did that? Who did that? Like, which action are we talking about here? So what happened? We sent a vote structure here. Like we packed it on the wire, sent it over. We even signed it like crazy, and arrived over there. It was tried to be unpacked by the contract, and it wasn't fitting the post action. It tried to decode it as a post, but it's a vote. So it wasn't the right action here. If I change that to vote, and then we cross our finger for large amounts of time, then we might succeed. Woo! Okay, so now we have posts. What about votes? So now we have the first vote registered. Ain't that cool? Yeah. Who do we vote for? Like, give me names. So we vote from Alice to Bob to 0, and then who votes? Come on, who votes? James, you didn't vote yet. And then votes, and then, okay, we have a few votes. Now remember that algorithm? I haven't shown you the algorithm, but you can take a look at this. This is all in the repo, right? This is going to be in the Shine repo under EOS Canada, so you can take a look. And all the Oompa Doompa happens in here, right? Whatever. It does some machinery. That's math. You want those math to be in there because they play with the money, right? And those are the rewards, And an awesome feature of EOS is that you can listen on actions that do not necessarily belong to you. Let's say you send a transfer. That's what we're going to do right now. You send a transfer to the EOS.io token. You know, there's a contract that manages the token, exchange EOS token and other tokens. It's a single contract. So some people are asking, like, does EOS have an ERC20 standard or whatever? It's one contract that manages all the coins. So it's super standard. And so that contract, when you transfer a fund from an account to an account, we're going to do that right now. I'm going to do that on the command line. EOS push action. I'm sending that to the EOS.io token contract and the operation over there. So the action name is transfer, and I'm going to say from. Let's say who has money in that system. Wait a second. EOS get currency balance for. Do I put that? EOS. Oh man, the account EOS.io. It's the main account that gets the initial monetary base. It is full of cash, right? We could take some of that because we're on a test net, obviously. We work elsewhere. So I'm going to transfer some EOS from that account to the Shine contract, and we're going to put a certain quantity because you're rich, so that's fine. Like 1,000 EOS at this day's price. It's good. And then a memo saying, I don't know, surprise. Okay, now if I do that, I'm actually talking not to the Shine account code, right? We're sending that to the EOS.io token contract, but that one has a feature to notify the from account and the to account. So it's sending a little message, and it will execute those two accounts. If there's code in there, it's going to execute with the source, the code name is going to be eos.io.token. So our code is able to distinguish if it's a call that was geared towards us or as a side effect of a call to the EOS.io token. That means we can react. And we have in our code that reacts to someone transferring us money. And how about when we send 1,000 EOS, we use all this waiting mechanism to dispatch a whole bunch of transactions to everyone who participated. Yeah. So I'm not exactly 100% sure. I think that's not possible on some other well-known blockchains. Okay, did we try that? So I'm going to hit enter here. I hope it works, and it should send a few EOS. And if the algorithm is good, we should see many transfers to Jane, Joe, whatever. Oh man, okay, cool. So what is missing? We need to tell him with which account we want to sign the transaction, obviously, right? You need to have at least one authority. So now we'll do that only if we manage the account for EOS.io to have all that bunch of cash at our disposal. Let's try that now, because I do have the keys for my testnet. Woohoo! So you see how the first transfer went? And then as a side effect, we also issued a transfer back to Alice for that amount. And if we take a look at now the Alice account, what? She now has some money too. How cool! So that's hopefully a concrete implementation of something on the blockchain, right? And you can try that very easily with a few tools. So, okay, now, so today we have launched a node on a single command line, EOS BIOS boot, remember that? And then we've looked at a simple app, a D-app, which is called Shine, which is an employee reward program. And then we implemented the command line tool in Go to interact with all these things. Join us on the channel so you can ask questions over there. And if you want to build anything using those tools, by all means come and see us, and we can retweet, we can share that, we can showcase them, because it's going to be a community effort. We want to see those things coming to life. We want to help you guys succeed in the hackathon and afterwards. And so don't hesitate to join our YouTube channel. This video is going to be on our YouTube channel. We post a lot of informational content that's usually as deep as that, and like we try to make it very solid. So that's EOS Canada. I thank you all for coming tonight. I hope you had a great time. We'll be around for a few things. There's still plenty of food there. Thank you very much.